In this video, we're going to continue 4.1. So all of this still applies, but today we're going to look more at this particular solution. So we start with our general. General solution, remember, is kind of the format of every original function. And since there are an infinite amount of them, we're going to integrate, but we're going to add this plus c in here. And so then we go to find this particular solution, which is going to, basically, we just need to find that specific value. And in order to do that, we will be given this initial condition in the form of an ordered pair. So we just kind of need a starting point. So everything else still applies. And we're just going to, actually, we're going to start with example 3, which is still a general solution. Here, remember we talked in the last video about trig functions. If we're asked to integrate trig, we need to make sure our integrand looks like one of these here in the highlighted box, okay? We cannot integrate a product, a quotient, or a chain. So if it doesn't look like anything in this box, then we can't integrate it. And so when I look at this problem, the very first thing I see is sine over cosine. So I'm going to rewrite this, and the reason I'm doing that is because I know that sine over cosine is the same as tangent. So I'm just taking these guys in the bottom, and I'm splitting them up. I'm kind of unmultiplying my fractions. So hopefully you see that if we were to multiply these, we would get right back to where we started. And the reason this is helpful is because I know that this guy is equal to tangent. And you can kind of even use your formulas to work backwards and almost cheat. The only one in this box that has tangent is this guy here. So we hope the other factor equals secant. And if it does, then we know the original function is secant of x. So if we come back here, 1 over cosine is equal to the secant of x. And again, this just asks the question, secant tangent is the derivative of what function? Well, it's the derivative of just the secant of x, and then just don't forget we have to put our plus c. Now we're going to find a particular solution, and in this case, again, when it says solve, it wants that original function, and it gives me an xy ordered pair in the original so that I can find that specific c value. So I do need to say that I'm going to integrate the derivative with respect to x. That's kind of the notation, since nothing in here tells me to integrate. So I do have to say I'm integrating. When we integrate, remember that reverse power rule, we're going to add 1 to this exponent first, and then we're going to divide. So whatever that coefficient is there, we're going to divide. Then here, again, we're going to add 1 to this exponent, and then we're going to take that coefficient and divide. And finally, -7 is the derivative of -7x. Just don't forget that we have plus c. And since this was f prime, when I integrate, I get f of x. So this is my general solution. In order to find that particular solution, I'm just going to plug this ordered pair in. So my x value is 3, so I'm going to have 1/3 times 3 cubed. Here I'm going to have 1 over 2 times, 3 squared, minus 7 times 3 plus c equals my y value of 1. And I know these numbers are confusing, I'm so sorry. But here we're going to get 27 over 3. Here we're going to get 9 over 2 minus 21. And if we simplify, we really get 9. I'm going to go ahead and convert this to a decimal. So combining like terms, we'll really have -12 plus 4.5. It's going to be -7.5. And I'm going to add 7.5 on both sides. And I see that c equals 8.5. So once we have that particular c value, that just means one specific, we plug that into our general solution. So remember, our general was here in red, and our particular is going to be the same thing, only it's going to have that c value. So I have a 1/3 x cubed plus 1/2 x squared minus 7x plus 8.5. And this is the particular solution that's in this form that goes right through this ordered pair.